All right, guys. Now I'm going to go ahead and move on to today's lesson, which is on section 2.3. 2.3 here. And I want to go over a couple of very important rules. In fact, they are our rules for the day, and they are the product rule and the quotient rule. So, product rule. So, if I want to find the derivative, d dx, of f of x times g of x. In other words, if I want to find the derivative of a product of two functions, now you'd think, in fact, I said this in the video, you'd think it'd just be the derivative of f times the derivative of g. Wouldn't you think that? Unfortunately, it's not. So here's the rule. The derivative of a product is f of x times g prime of x plus g of x times f prime of x. That is the product rule. It is in the notes. We're going to use it today. I'm telling you, you need to memorize it. That is the rule. Now, in the video that I posted on Canvas that I made, 3 weeks ago, I go through and kind of explain why it's not what you'd think it is. Why is it? It doesn't seem like it should be this. So what I'm going to do right now is I'm actually going to show you a proof of the product rule. Now, the proof I'm getting ready to show you, two things I want you to be aware of. Number one, do not write it down. What I'm getting ready to show you, do not write it down. Number two, I am never going to ask you to write the proof of this rule. I am only showing it to you for educational purposes. Okay, does that make sense? All right, so we need to start from the beginning. So, product rule. So what I've done here is I've got it all typed up into this PowerPoint so that it'll go really fast. So we're trying to find the derivative of f times g, correct? Okay, so by our definition of a derivative, that means I've got to do the limit as delta x goes to 0 of f of x plus delta x times g of x plus delta x minus f of x times g of x over delta. Does that kind of look familiar? Remember last week I said if you got a tattoo of anything on your, or actually 2 weeks ago, if you got a tattoo, get this tattoo. Anyways, that's what that is. Okay, now I'm going to do a little trickery here. Okay, first of all, notice that this is exactly what we have there. But what I'm going to do is I'm going to add a couple of terms right here. I'm going to put f of x times g x plus delta x. But by the way, if I add that in there, guess what I have to do to make sure I don't screw up the quality of this? I'm sorry, if I minus that there, guess what I have to do? I got to add it back. So be aware, these two blue terms are actually how much when we add them together? 0, right? So this is equivalent to this, agreed? Okay, great. Now, we're going to break this into two parts. I'm going to take these two terms and I'm going to pull them down here. And I'm going to take these two parts and I'm going to pull them down there. So I've taken this one limit and I broke it into two. Are you with me? And by the way, that's allowed. So far, so good? Again, you're probably thinking, wow, this is really crazy. Again, I'm never going to ask you to do this. Okay, do you notice anything that these two guys have in common? Do you notice anything that these two guys have in common? So I can pull out that g of x plus delta x, correct? By the distributive property. And what do these two guys have in common? They have that f of x in common, right? So guess what I can do there? I can pull that out. Now, again, you're probably thinking, okay, this is getting, I don't know if this is getting better. Maybe it looks a little bit better. Now, this right here is exactly what we had on the last step. Okay, so I just recopied it right here. What is delta x going to? A 0, right? So if I put 0 in here for delta x, what's that going to give me? Oh, actually, I'm sorry, I skipped a step here. Okay, here's another limit. This is technically the limit of this, okay? So that's, we can now do the limit of this part, and we can also do the limit of that part. Same thing here. Okay, here's what I'm trying to say. If delta x is going to 0, what does this become right here? Just g of x, right? Now, biggest, most important question. Does anybody recognize what this is? It's the derivative of f of x. Remember that thing I said you could get a tattoo of? That's f prime. Of course, delta x is going to 0. There's no delta x there, so that's just f of x. What's this? That's the derivative of g of x. Now again, by the way, QED just means that the proof is finished. I'm going to get out of this here for a second, and I'm going to go back to what I just said here. Now, do you believe me? This is true. I'm not being tricky. This is actually the proof, and this is the rule for the quotient or the product rule. Now, I'm going to give you the quotient rule, and I'm just going to give it to you. I'm not going to prove it to you, okay? But just trust me that what I'm telling you is correct. So the quotient rule for differentiation is if I have f of x divided by g of x, and that is going to be the same thing as g of x times f prime of x minus f of x times g prime of x I'm going to write the bottom a little bit differently than your book might have, and I'll explain why in just a second. By the way, the bottom is the same thing as g squared, right? I'm just going to write it as g of x times g of x. Now, I'm not going to show you the proof of this one. There's one out there, but let's not worry about it. Just trust me that that's the rule. So what I'm telling you is if you have, let me let you finish writing that down. If you're trying to find the derivative of a quotient of two functions, this is the rule. This is the shortcut. Think about that proof I just did. That proof was pretty ugly, wasn't it? The proof for this one's worse, right? Because quotients are in general are worse. You don't have to go through all those steps. You will simply use this. This is the shortcut. If I ask you what the derivative of f of x over g of x, it is not the derivative of f over the derivative of g. It is this. Now, do those seem kind of manageable? Can I give you, I'm going to give you one more thing here, and you guys can tell me if you want it or not. Can I give you maybe an easier way to remember it? Do you guys ever remember this saying called, please excuse my dear Aunt Sally? What's that for? PEMDAS. What's that for? Right, parentheses. Yeah, it's for remembering the order of operations. Do you guys remember that? Please excuse my dear Aunt Sally. Okay, anyways, I'm going to give you something similar to that right now. If you like it, I use it. I still use it. Okay? If you would, you could kind of think about that as the first one and then the second one, right? First and second. This is the first function, and then this is the second function. So here's what I do for this rule. I just write this to help me remember it. So this is the first. That was the first one, right? Guess what D stands for? Derivative of the second one. So it's 1d2 plus 2, which is the second one, and times the derivative of 1. Does that make sense? So let's, if you guys don't mind, let's say that together. Ready? 1d2 plus 2d1. Let's say a little bit faster. Ready? 1d2 plus 2d1. Now, I'm telling you guys right now, I still remember this now. And I've taught calculus many times. But this helps me remember the rules so I don't screw it up by accident when I'm trying to explain stuff to students, although I still screw stuff up occasionally. Okay? Would you like another rule for this one that's maybe easier to remember? Okay. And by the way, let me make sure is this the rule right here? That is not the rule. If I ever ask you what the rule is, do not tell me that's the rule. If I ask you what's the trick to remember the rule, you could say that. This is the rule, right? Okay, so here's another little trick, if you will, to remember this one. Ready? Okay, we would think about this guy. I'm going to call this guy, that's like the low one, right? And that's kind of like the high one, right? So the function on top is the high one, the function on the bottom is the low one, right?
Yeah.
So here's the rule. Now you can see I'm even abbreviating that a little bit, right? Here's what it says. Low D high minus high D low over low low. Can we say that together? Low D high minus high D low over low low. Let's do a little bit faster. Ready? Low D high minus high D low over low low. Now, guys, I'm telling you, I know it's silly. And when I was in your shoes and my math teacher would say something silly like that, I'd be like, I don't need that. Okay, that's fine. Don't use it. I'm telling you what, guess what kids remember 10 years later? When I asked you what please excuse my dear Aunt Sally is, and when was the last time someone talked about that with you? A long time ago, wasn't it? And you all, most of you remembered that, didn't you? You'll remember this. Okay? Now, I'm going to do one more example with you here, but I'm going to pause my video because I think I'm where I need to stop it.